Every single human being on Earth right now descends from dark-skinned ancestors in Africa. Everyone. So why do some of us look like we've never seen the sun in our lives? The answer involves vitamin D, a nutrient called folate, and one of the weirdest evolutionary trades our species ever made. And no, it did not happen the simple way you're picturing. And before you picture this as some straight line, dark skin on one end, light skin on the other, done. I need to stop you right there, because that is not remotely how this actually went down. This is messier, weirder, and honestly way more interesting than a straight line. Let's actually get into it. Quick thing before we dive in, if you're new here, we cover ancient history and human origins like this every week. Real science, zero boring textbook energy. Hit follow now so you don't miss the next one. So here's where this actually starts. And it's further back than most people think. Over 1 million years ago, with an ancestor of ours called Homo erectus. At some point, our ancestors evolved to lose most of their body hair. Scientists think this happened because we were developing a genuinely incredible cooling system: sweating. Losing body hair let sweat evaporate off bare skin way more efficiently, which meant our ancestors could run, chase, and hunt for way longer distances in hot climates than basically any other animal. It's actually one of our secret superpowers as a species. But here's the problem. Once you lose all that hair, your skin is suddenly getting hit directly by intense equatorial sunlight, all day, every day for the first time. And that sunlight is dangerous. Not just sunburn dangerous, it actually breaks down a nutrient in your bloodstream called folate, which your body desperately needs for healthy cell division and reproduction. Too much UV exposure without protection means folate damage, which historically meant real reproductive problems. So evolution did what evolution does. It found a fix. Skin cells started producing way more of a pigment called melanin, which is basically a built-in natural sunscreen. The darker the skin, the more effectively it blocks UV radiation and protects that crucial folate supply. This is why our early ancestors in equatorial Africa evolved dark skin. Not as some cosmetic trait, but as a literal survival mechanism protecting their ability to reproduce successfully in an intensely sunny environment. Okay, so dark skin made total sense in Africa. Everybody's protected. Everybody's fine. So what happens when humans start actually leaving Africa and heading toward parts of the world with way less intense sunlight? The migration problem. So, starting tens of thousands of years ago, groups of humans start migrating out of Africa into higher latitudes, places like Northern Europe and Northern Asia, where sunlight is way weaker, especially seasonally. And here's the twist: the same dark skin that was a lifesaver near the equator suddenly becomes a liability. See, your skin doesn't just need protection from too much sun. It also uses sunlight to actually manufacture vitamin D, a nutrient your body needs for strong bones, a functioning immune system, and a bunch of other essential processes. Dark, heavily pigmented skin is great at blocking UV rays, but that also means it blocks the UV rays your body needs to make vitamin D. In a place with intense, year-round sunlight like equatorial Africa, that's not an issue. There's more than enough UV getting through regardless. But in a low sunlight environment like Scandinavia, dark skin might not let enough UV through to make sufficient vitamin D, and that leads to real health problems. Weakened bones, a condition called rickets, immune issues, and reduced reproductive success over generations. So evolution, once again, found a fix. But this time in the opposite direction. In populations living in these lower UV regions, natural selection favored lighter, less pigmented skin, because lighter skin lets more of that limited sunlight through to produce enough vitamin D to stay healthy. This is called the vitamin D folate hypothesis, and it's currently the leading scientific explanation for why human skin color varies the way it does across different parts of the world. It's not about beauty standards or random chance. It's a direct biological trade-off between protecting folate near the equator and producing enough vitamin D everywhere else. Now, here's the part that genuinely surprises most people, including a lot of adults who think they already know this whole story. Lighter skin didn't evolve once and then just spread around the world. It evolved more than once, completely independently, using completely different genes. So this is the part that completely breaks the straight line from dark to light idea. Scientists have found that lighter skin pigmentation evolved independently at least a few different times in different populations using different genetic mutations that just happened to produce a similar end result. Populations that became the ancestors of modern Europeans developed lighter skin through one specific set of gene variants. Populations that became the ancestors of modern East Asians developed lighter skin through a largely different set of gene variants. Same basic outcome: lighter, more UV permeable skin, but arrived at through separate evolutionary paths at different points in time, completely independently of each other. This is called convergent evolution, and it's honestly one of the coolest concepts in all of biology. It's when evolution solves the same practical problem multiple times in different populations using different biological tools because the environmental pressure driving it is the same. In this case, the problem was low UV environments needing more vitamin D production, and multiple separate human populations landed on a similar solution independently without any of them copying each other because they weren't even in contact. And here's another detail that really breaks the simple narrative. Some research even suggests certain early human ancestors, way before modern humans existed, may have actually had lighter skin covered by dark hair, similar to what we see in chimpanzees today, before eventually evolving both hairlessness and dark skin together in Africa. So even the very starting point of this story isn't as simple as dark skin, always from the very beginning. This entire process has been way more complicated, way more looping, and way less linear than the average textbook diagram makes it look. So if it's not a straight line, and it happened more than once independently, what does the actual global pattern look like? Turns out, it's not really about groups at all. It's about something way more precise. Here's what researchers actually found when they mapped this out using satellite UV data compared against indigenous skin tones around the world. Skin color tracks incredibly closely with UV radiation levels by latitude, forming a smooth gradient. Scientists call it a cline, rather than distinct, separate categories. Populations closest to the equator, where UV is strongest year-round, have the darkest skin. Populations at higher latitudes, where UV is weaker and more seasonal, have progressively lighter skin. There's no hard line where one type suddenly becomes another. It's a gradual, continuous slide that matches sunlight intensity almost precisely. This is a genuinely important point because it means skin color is fundamentally a response to environment and geography, not a marker of separate, distinct biological categories the way race has often been framed historically. The researcher who did much of the foundational work on this, Dr. Nina Jablonski, has been explicit that these pigmentation differences are adaptive traits shaped by UV exposure, not evidence of any deeper biological division between groups of people. Two populations living at similar latitudes, even on completely different continents with zero historical contact, tend to have converged on similar skin tones because they were responding to the same environmental pressure, not because of any shared ancestry driving it. And there's a genuinely wild modern twist to this story too, because humans now travel and relocate way faster than evolution can keep up with. Someone with skin that evolved over thousands of years for a low UV environment can now live somewhere near the equator within a single lifetime, and vice versa. That's part of why modern conversations around sun safety, vitamin D supplementation, and skin cancer risk are so directly tied to this deep evolutionary history. Our skin is still, in a very real sense, adapted to wherever our distant ancestors lived, not necessarily to wherever we personally live today. So here's the actual takeaway. This was never a story about humans going from one fixed category to another. It's the story of a single adaptable trait, skin pigmentation, responding to one of the most basic environmental pressures on Earth, sunlight, over hundreds of thousands of years, in multiple independent populations using different genetic tools to arrive at similar results. It's less black to white and more one incredibly flexible biological dial, tuned differently depending on exactly how much sun your ancestors needed to survive and reproduce successfully. Every version of this story, dark skin evolving for folate protection, light skin evolving independently more than once for vitamin D, is honestly a way better story than the oversimplified version most of us grew up with. If nobody taught you the actual science behind this in school, follow. We cover ancient history and human origins like this every single week. Comment which part of human evolution or ancient history you want broken down next, because there is so much more where this came from. And if you want more of this same, wait, that's not actually how it happened energy, check out the Cleopatra video linked right here. Completely different topic. Same kind of plot twist.